This is the high frequency generation system. It is split into three systems: DC, sine wave and square wave. Each of these systems has their individual power supply and they have the vacuum chambers at the top. Vacuum is generated through the central system for all the three power supplies. We will now run through the operation for the square wave generation. First, we will switch on the power and the vacuum in the central system. Now we will generate vacuum and pass this to the plasma chamber of the sine wave generator. This plasma chamber is being evacuated and we will start the operational procedure for the square wave generator. Now we will look at the operation of the square wave generator. On the top panel, we will turn on the MCB. Then we will turn on the power switch. Post that, we will switch on the inverter and wait for the inverter to completely switch on. This will be the first view that you get. We will go into menu, display parameters to check the frequency. At the moment, the frequency is set to 20,000 Hz or 20 kHz. The inverter is in off condition. We go into on-off to switch on the inverter. Once this is complete, the high frequency generation system is ready, so we can supply the high voltage. We switch on the high voltage and we can view the high voltage on the panel meter. To increase the voltage, we will use the voltage knob. We have a timer available to set the exact time for the sample. Once this is set, we will press the start button and raise the voltage. As we raise the voltage, you can observe the panel meter. The voltage will raise. Simultaneously, the chamber will show you the high frequency plasma being generated. This plasma is being generated between the two electrodes in full vacuum condition. Now, we will show you the method to switch off. First, we reduce the voltage to 0. Next, we turn off the high voltage. We continuously observe the voltage here to ensure it goes to 0, and in the meantime, we can switch off the inverter. Disconnect the inverter. Ensure that the voltage is less than 1 kV. Turn off the power switch and switch off the MCB. For any system, to completely ensure there is no voltage before we touch the chamber, we have a discharge stick available. We will pick it up. It is already connected to ground. We hook it to the high voltage connection. We place it back in its position. Now you may freely touch the plasma chamber. Now we move to the working of the sine wave generator. This is the central system which has the vacuum controls for the other two systems. As you can see, the square wave system is still connected to the vacuum. We will pull out the pipe after ensuring vacuum is off and connect the sine wave pipe. Once this is completed, the square wave system is entirely disconnected from the sine wave system. Now we will turn on the MCB for the sine wave system. Please note, there is a separate MCB also. Both have to be turned on. Next, we will switch on the key switch of the sine wave system, and then we will switch on the vacuum for the chamber. Please note, there are two chambers on this system. This chamber is internally connected to the sine wave system. This chamber can be externally connected to the sine wave system using the connectors present at the top. The blue cable and the left connector is the ground connection. Orange connector on the right is high voltage. There is a decoupling capacitor at the back, which we will explain at a later stage. For the moment, we will see the working of the internally connected plasma chamber. Once the vacuum is switched on, we will now switch on the sine wave system, and this is the knob to vary voltage. There are a few different controls here. We recommend usage of the 20 kHz frequency, where the switch is in the top position and the variable frequency is set to 20 kHz. There are 4 different options: 5, 10, 15 and 20 kHz. At the moment, it is set to 20 kHz. We will use this knob to increase the amplitude of the output. As you can see on the panel meter, the voltage is increasing internally. Once we achieve certain voltage, there will be plasma generated between the electrodes of the chamber. You may place your sample in between the electrodes so that the plasma may affect the sample. The same holds valid for the externally connected plasma chamber. You will connect these here and proceed with the same setup. Now we will show you turning off of the system. Reduce the voltage. Once it is at the 0 position, you wait for the voltage to drop in the panel meter. You can always view the output of any of the waveforms from the output BNC terminal. Once the voltage is less than 1 kV, you can freely turn off the power, switch off the vacuum, switch off the mains. To discharge the voltage, you will release the vacuum of the chamber, lift the glass top off, use the discharge stick to touch the top electrode, which is the high voltage electrode. Hold it for a few seconds till the discharge is complete, and then you may let go. For the external chamber, you may touch it to the top. Now we move on to the DC system operation. First, we change the tube to connect the plasma chamber of the DC system into the vacuum system. Power on the central system, start the vacuum and start evacuating the chamber. This chamber is housed on top of the DC system itself. and vacuum is being generated. Now we will see the demonstration of the operation of the DC system. Turn on the MCB, power on the key switch, switch on the high voltage. Using the knob, you can slowly raise the voltage and observe the output of the plasma generator. As you can see, the plasma generation has started. Once your experiment is complete, to turn off the system, reduce the voltage, switch off the high voltage, turn off the key switch, switch off the MCB, discharge the plasma chamber before touching. This is especially important for the DC system as there is an internal capacitor which will remain charged if not completely discharged. You can hook it here for a minute or two if you like. Once it's complete, replace the system, and this completes the operation of the entire set of 3 systems.